Hello dear students, today we will start with the next lecture of mechanics, Kepler laws of planetary motion. This is very important question for exam. You might have studied Kepler laws in 10+1 class as well, but there the proof of these laws are based upon that Earth revolves around Sun in a circular orbit. But here a true proof, because as we know Earth does not revolve around Sun in an circular orbit, rather it moves in an elliptical orbit. So in B.Sc class we deal with the proper trajectory, elliptical orbit of the Earth around Sun. First law: all planets revolve around Sun in an elliptical orbit with Sun at one of the two foci. Of the elliptical path. That is, suppose this is the elliptical path, this is the major axis, this is the minor axis, and this elliptical path have two foci. Foci is plural of the word focus, and Sun is present at one of them. Sun is present at one of them. Suppose Sun is present here, and our planet, say Earth, it is revolving around Sun in an elliptical orbit. This is major axis, we take it equal to 2a. This is minor axis, we take it equal to 2b. A is greater than B, so this is a elliptical path. So now we will prove it. So in lower classes we have only laws, no proper proof for the elliptical orbit, but here we can prove it because we have done a lot regarding the motion of an object in an inverse square field in the previous lectures. The centricity of the orbit is given by orbit in which the planet revolves around Sun is given by E is equal to square root 1 plus 2E L square upon mu k square. As Sun and planet is a bound system, Sun and planet forms a bound system, so the total energy of the system is negative. For a bound system, total energy is negative, so E will be less than 1. If the centricity is less than 1, then the trajectory or the path will be elliptical in nature. Coming to second law, in Kepler second law, it is stated that the line joining the planet and sun, the line joining the planet and sun sweeps equal area in equal interval of time. That is, the aerial velocity of the planet is constant. This is the elliptical orbit, and this is sun. Let the planet is at position P1 at any time t, and this is the line joining the sun and the planet. Let this position vector is r vector, and after some time the planet revolves in an anti-clockwise direction, reaches point Q. Let this vector is dr vector. Dr tends to 0. Point Q is very close to position Q. Join this, then this vector will be r vector plus dr vector. Then the line joining the sun and the planet sweeps this area. And we are to prove that aerial velocity while traversing this area is constant. So if we suppose this small area equal to dA vector, it is the area swept by line joining the planet and sun in time dt in moving from P to Q. So as the earth moves from point P to Q, dA vector is the area swept by line joining the planet and sun. So area vector will be equal to half r cross dr. It is by definition of cross product. Divide both sides by time. dA is area, divide by time, so it will become aerial velocity r cross dr by dt. So this is the aerial velocity. This is the simple velocity, linear velocity of the planet. So dA vector by dt, it is equal to half r cross velocity. So here multiply and divide by mu. So we get 1 by 2 mu r cross mu b. Here mu is the reduced mass of the planet and sun system. Mass into velocity is linear momentum. So r cross p is angular momentum. This is constant. Why this is constant? Because under a central force, inverse square law force, L is constant both in magnitude as well as in direction. We have proved it in one of the previous lectures. So dA by dt is constant. That is, aerial velocity of planet is constant. So this is our second law of planetary motion. Now we come to third law. Third law, it states that square of time period of the planet when it revolves around sun is directly proportional to the cube of semi-major axis of the elliptical orbit. That is, square of the time period is directly proportional to cube of semi-major axis. Because major axis we represented it by 2a, then semi, half of that will be equal to a. Semi-minor axis b, semi-major axis a. So proof of this, this is the elliptical orbit, semi-major axis, semi-minor axis. So time period of the planet is given by it is total area of ellipse, because planet revolves around sun in an elliptical orbit, divided by areal velocity. Area of ellipse is pi AB. Areal velocity is L upon 2 mu in magnitude. Here we proved it. So time period will come out to be 2 mu pi AB divided by L. As we have proved, for the conic in which the planet is revolving around sun, semi-latus rectum, it is given by b square by a, and semi-latus rectum is related to total angular momentum by formula mu L square by mu k. So if we combine the two, so L square is equal to b square mu k divided by a. So L is equal to b mu k divided by a. So from 1 and 2, time period will be given by 2 mu pi a b divided by L. L is b mu k divided by a. So b cancels. So time period will be 2 mu pi a root a upon mu k. So 1 mu cancels here, square root of mu will be left. So it will be t is equal to 2 pi under root mu a cube divided by k. This a, when it goes inside, it will be a square. Squaring both sides, t square is equal to 4 pi square mu a cube divided by k. So t square is proportional to a cube. So this is Kepler's third law. Square of the time period is directly proportional to cube of semi-major axis. Dear students, this is very important question for exams. So that's all for today. Keep in touch. Thanks a lot.